Hello and welcome to the fifth video in this series on the binomial expansion, and in this video we're going to be looking at the applications of the binomial expansion to help us look at some probability questions. And we're going to look at the binomial distribution. So we've got a couple of questions here. We will look at these in a moment. First of all, we're just going to consider what is meant by a binomial distribution. So there are various conditions that have to be met in order for a distribution to be binomial. So the binomial bit means there needs to be two options, so two outcomes. So we normally define those as success and failure. So if there's more than three outcomes we're interested in, then it's not appropriate. The second condition that we have to have is there needs to be a fixed number of trials. And the third is there needs to be a fixed probability of success. So when we have a situation where those three things are all in place, then a binomial expansion or a binomial distribution could be appropriate. So let's have a look at these two scenarios. So a particular variety of apple seed has a 0.56 probability of germinating. Lucinda plants 40 of these seeds and waits to see if any will germinate. Could this situation be modelled with a binomial distribution? Well, let's consider those three things. So, is there a binary choice? Well, yes, there is. Either it will germinate or it will not germinate. So that condition is met. Is there a fixed number of trials? Well, yes, there is, because Lucinda is planting 40 seeds. And is there a fixed probability of success? Well, we can assume there is, because it tells us the apple seed has a 0.56 probability of germinating. So all three of those conditions are met, and therefore this is appropriate to be used as a binomial distribution. And we can record that by saying X is a binomial distribution, and then we have a bracket or a pair of brackets, and inside the brackets we put the parameters for our distribution, and there's two pieces of information that are included here. The first one is the number of trials, so in this case 40, and the second one is the probability of success, which in this case is 0.56. Okay, the B is really important here for binomial distribution, because if you study probability distributions to a greater extent, then we look at different ones, and there's several which have two numbers in brackets separated by a comma, and then we can tell the difference between what information is there by what type of distribution. So in this case, B for binomial. So let's look at the second scenario then. So a particular variety of flower can bloom in 3 different colours with an equal chance of each colour blooming. Lucinda has 30 of these flowers and waits to see what colour they will be. Could this situation be modelled with a binomial distribution? So let's think about what we've got. Well, it tells us there's an equal chance of each colour blooming, so that means we have a fixed probability of one blooming. It tells us that there's 30 flowers, so we have a fixed number of trials, but it's not a binary choice, because it says Lucinda's interested in what colour they will be, and there's 3 possible colours. Now, if this question was worded slightly differently, if it had said, it can be red, yellow or blue, and she's interested in the probability of getting a red one, now that then would be binary, because the yellow and blue would be irrelevant. It would just be red or it's not red. But in this case, it's not appropriate to use a binomial distribution. Those rules just come up on the screen there that I mentioned earlier about the conditions that have to be true for a binomial distribution. So now we're going to actually do some calculations, and this is where the binomial expansion comes in. So a particular variety of apple seed has a 0.56 probability of germinating. Lucinda plants 40 of these seeds and waits to see if any will germinate. So the same information we looked at a moment ago. And we said that that could be modelled as a binomial distribution with the parameter 40, 0.56. It's 40 trials with the 0.56 probability of success. Model the situation as a binomial distribution, which we've done, and then find the probability that exactly 25 will germinate. So we're going to look at the probability that x is 25. So the probability that exactly 25 germinate. So we look first of all at 40C25. That will give us the number of different ways we can select 25 from the group of 40. We are then interested in 25 germinating, so probability 1 germinates 0.56. We raise that to the power of 25, and therefore the other 15 are going to fail to germinate, and that is 0.44, and that's because these two must sum to 1, because they germinate or they don't germinate. There's no other option. It's a binary choice. And now I can type this into the calculator. And that gives me 0.0914. So what's that? That's 3 significant figures. That might be all right. Maybe I'll just go for 4 significant figures. So there we go. So that is our probability that exactly 25 will germinate. Now, depending on the calculator you've got, you may have one that has a distributions function. And if it does have a binomial distribution function, you can probably find somewhere where you can type in the parameter of 40 and 0.56 as your values of n and p, and 25 is your value of x, and that will give you the probability without having to actually use the binomial expansion itself. Okay, so here are some questions for you to have a go at. So the first 6 questions there, you have it written out as a distribution in some statistical language, and you're evaluating the probability in each case. And then G, H, and I, you're going to have to think about how you can model it first of all. And here are the answers.